Alright, chapter 53, part 2. Sorry, I ran out a little bit of time. And so, again, primary succession. And the last one, succession, is just how the land changes over time. So, primary succession means you have to have lifeless soil. And so, no soil, you don't have bacteria, lichens, mosses. They're in the soil. Grasses, shrubs, trees. And so again, that's only really going to happen during lava and really after glacier retreats when there's nothing in there. The next part is secondary succession. And so perfect example is the forest fires. And so there's still life in there. Most everything's burned, but there's a lot of life, a lot of trees that actually need that fire in order for the pine cones to go out again. So over time, you're going to get this pretty meadow with flowers. And succession starts all over. We have different things called pioneer species. So these are the first things to settle. It's pioneer. So lichens and mosses. And then you get the grasses. And they start coming next because they compete well in high sunlight. So it's not a lot of shade because, again, there's no trees or anything. And so they compete really well. And then you get bushes and small trees. They're a little bit more shade tolerant. And then you start getting the tall trees, and they are shade tolerant, so the babies can live in the shade. And that would be our nice stable community, the climax forest. So what is causing succession? First of all, tolerance. Early species of weeds are selected, and so they're going to reproduce quickly, put out lots of young, and they're tolerant of harsh conditions, so they easily come in. After that, you start getting some more facilitation and inhibition. Early species facilitate habitat changes. They'll change the pH of the soil, the fertility, light levels, and other species actually start to outcompete them. So we have our pioneer over here in year 1, but as it goes on, it becomes more into the spruce forest, and what really is showing you is how much more nitrogen as things come. The climax forest is a plant community that's dominated by trees, and it's the final stage of a natural succession for a specific location. It's stable and it becomes unchanged as long as it's undisturbed. Example, this birch, beech, maple, hemlock. Can also be the oak, hickory, and pine. And so you can kind of see the 2 different stable communities. And so depends on where it is. So how much rain, how much sun, temperature, depth of the soil. So this is typical in the taiga, more what I see here. This would be more in the temperate deciduous forest out east, so the birch, beech, maple, and hemlock. Disturbances are a natural cycle. They do need fire in order to, and so we need fire with that, but that releases the nutrients, increases the biodiversity. So it's a big, and so we had, for instance, a lot of fires this summer. What happens is we try and get rid of forest fires, and meantime, these trees want to burn, and so that they can release these nutrients, and you start getting this kind of cycle that the less we let the forest burn, the more they're going to burn. Plus we also have the beetle kill, which is killing a lot of the trees right now, which one of the only ways to kill those is, again, to let the forest burn. I'm not saying I want all of Colorado to burn. It's pretty upsetting. That's kind of where we are right now. So if we do let it burn, we have increased habitats. It rejuvenates the community. And so we have these fire climax species. This jack pine that, again, is not going to release its seeds until after a fire. And so that's the way they reproduce, is having frequent fires. Now, we build homes all the time in fire climax zones. And so we saw it all over the state this year, and it is very devastating. And like I already said, preventing fires makes next year's fire that much worse. And we will be talking about in the class, so if you have any questions, please let me know.